Alright, this video is going to be going over simplifying complex rational expressions. I'm just going to go over a couple examples just to kind of give you a heads up on how to do them. Alright, so here's our problem. What makes a expression complex is when there's a fraction within the fraction. So in math, it's bad to have a fraction in a fraction. It's considered to be an unsimplified problem when that happens. So you're always going to try to make the fractions disappear and just have a typical numerator-denominator fraction. So if you see here, we have a fraction in a fraction. All right, so what you do is you look at all the denominators. So we have 4x, 4x. So every denominator is 4 or x. And you're going to multiply everything by something that all those can go into. So in this case, it's easy just to multiply them together. So you're going to multiply this whole thing by 4x. So the goal of this is to get rid of your fractions in the fraction. So it's okay to have a fraction, we just don't want fractions in the fraction. So we're going to write this out so we can see, what exactly you're doing. So all I'm doing is take every term that is in that expression. We're going to multiply every term by 4x. So we'll do it the long way the first time, and when I do the second example, you'll understand what we're doing. But all right, so remember when you're multiplying, it's numerator times numerator, denominator times denominator. So these are basically all over 1. So we're going to do x times 4x, which is 4x squared. Sorry, I can't get everything on the paper. And then 4 times 1, which is 4. So this expression, this term, has turned into this term. Minus, and 4 times 4 is 16, 16x. And then x times 1 is x. So that's our top. And then our bottom is 1 times 4x, which is 4x. And then 4 times 1 is 4. So that's term turned to this. And then 1 times 4x is 4x. And then x times 1 is x. So here's our new complicated looking still expression. But the nice thing about this part is where we can simplify it. So when we simplify this, if we chose the right number to multiply by, that all the denominators should disappear in this case. All right, so if I look at here, we can cancel out those. And we're left with just x squared. And then if we look at these, the x and the x cancel out and leave 16. So remember, this is just dividing them out. If I divide 4 by 4, I get 1. If I divide 4 by 4, I get 1. 1 on the bottom is not important on a fraction, so you can just leave it off. And then the bottom, if we cross these off, we're left with x. And this bottom, cross those off, and we're left with this. Now this is where your prior knowledge comes into play. Always see if you can factor it before you say, okay, I'm done. So this is the difference of squares. If you remember, the difference of squares looks like that. The bottom we can't really do anything with, but we can cross those out. So our final answer is x plus 4. So that is a simplified version of this nasty thing that we started with here. I guess it would be here. So we found what all the denominators went into, and we multiplied every single term by those. So every term, whether it is a fraction or not, you will multiply that by that. But in this case, all of them were fractions. So when we multiplied that by that, we simplified to x squared. When we multiplied this by this, We simplified to 16. And then when we got to this part, I had a difference of squares. And then I was able to cross those off because they're the same on the top and the bottom. And then we're left with x plus 4 as an answer. So let me give you one more example. And again, if this doesn't make sense to you, please contact me. I'll be happy to help. Now this one doesn't have any x's in it, but it still works the same. So this works if you have one fraction in a fraction or a billion fractions in a fraction. And it doesn't have to have a variable in it for this to work. I mean, we could go ahead and do this a long way and find the common denominators between the two and then add them and then divide them at the end, but this works so much faster. So I look at the denominators, 4, 3, 3, and 4. So 4 and 3 are my denominators. 4 and 3, what they have in common, which means what is a multiple they both share. So remember, multiples are 3, 6, 9, 12, da 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 da. Well, 12 is that multiple they share. So that means I'm going to take this whole thing and I'm going to multiply it by 12. And that's every term. Now, when you've done this enough, you can kind of go from this step to the step right after this without writing it out, but you have to do it a few times to be able to get that good. Well, I wouldn't say a few times, I say a lot of times. So I can go ahead and multiply across, or we can just simplify it here. So 4 goes into 4 once, 4 goes into 12 3 times. 3 goes into 3 once, 3 goes into 12 4 times. So I'm going to go ahead and finish off the top. So 1 times 3, and there's 1 at the bottom, which means absolutely nothing. And then 2 times 4, which is 8. So our top is looking good. And the bottom, 3 goes into 3 once, 3 goes into 12 4 times, 4 goes into 4 once, 4 goes into 12 3 times. So if you're not good at the reducing, that's basically all you're doing. Is just think about what can go into both of those and then go ahead and pull it out. Some people like to write it out and then they can see that both of those can be divisible by 3. And that's what we're left with here. All right, but that's just a kind of side note. All right, so the bottom's gone. So we have 2 times 4, which is 8. And 1 times 3 is 3. So we get 8 plus 3 is 11. And 8 plus 3 is 11, which equals 1. So same premise, getting rid of the fraction in the fraction. He's going to find one more in your book. And let's do this one. 1 plus 1 over x. 1 minus 1 over x. All right, so this is a good example to show you, to make sure that you understand that even if it's not a fraction, you want to multiply it by that LCD that you find. All right, so I look at all the denominators. This does not have one. Well, it does, it's just 1, so it doesn't matter. So this is a denominator, this is a denominator. So both those are x's, so of course we're going to multiply by x. So we have 1 times x plus 1x times x. So 1 times x minus 1 over x times x. So all I did there was just multiply everything by x. Don't forget to do the terms that aren't even fractions, because if you don't, you're going to mess it up. Basically in math, there's all kinds of legal functions you can do. As long as you do it to everybody, it makes it legal, and that's what we're doing. We're multiplying everybody by the same thing, so it makes it illegal. All right, so 1 times x is x. These will cross out because x on the top, x on the bottom equals 1. X on the bottom, and these will cancel. And then, of course, there's nothing we can factor anymore on that. Don't be tempted to cross these out because that's an illegal math function. If these are separated by minuses or pluses, then these are a group, which means they have to stay together. So you can't cancel these off because these two actually are married, I should say. The same with this. So the only time you can cross them off is if they're multiplied together. Then it's okay to do that. But when they're added or subtracted, that's as far as you can go. Let me do one more. One over x minus 1y. 1 over xy. Yeah, they don't give you a whole lot of examples, but you'll build on this. You'll use this in the expressions and you'll build on it when it becomes equations. All right, so we're going to look at all our bottoms. We have x, we have y, we have xy. So if we multiply everything by xy, we will take care of all the bottoms. So 1 over x times xy, 1 over y times xy, 1 over xy times xy. So remember, when you're multiplying by this number, whatever it is that you find, this is the numerator. These are all basically over 1, and the rules for math for fractions are numerator times numerator, denominator times denominator. All right, so we can kind of simplify these as we go. So, and these can be crossed off because these are multiplied. As long as you multiply together, they're not married. But if this had x plus y, then we couldn't cross them off. So those x's cancel out and leave a y there. And then this y and this y will cancel out and leave just an x. And then this xy and this xy cancel out and they leave a y1 on the bottom. And anything over 1 basically is itself. So I hope that was enough explanation to get you to understand. If not, let me know and I will be happy to give you more examples.